Hello everybody, here's Mr. C. This is a recording to help you with Lab 4.3 where we're going to determine the specific heat, the heat capacity of these metals here. Just a intro slide here. I'm going to go over it, what you need to do, and emphasize the tricky things. It's not too tricky, but two things I want to point out to you that always get some students, so I want to help you out there. This is the tutorial. You can go through the tutorial by yourself and gonna get as much out as probably as I do here, but I'm gonna show it to you probably quicker. So when we begin the lab, you select your favorite glove as usual, and we end up here. I'm gonna move that into the screen. So we have a workbench and we have our styrofoam cap. Looks like more like a metal cylinder. It is a dewar that thermally isolates what's inside to the outside world. And we have some weights here with the unknown metal, and we're going to determine the type of metal that's on these weights. There's only one type here, by finding their heat capacity and then going to a table and determine what material that is. The first thing is, what you want to do is, before you start this lab, is you want to press the on button of the heater. I usually move the stopwatch a little bit out of the way. It's on high, and it will take a little while until the water starts boiling. That's why just get going on it, and I think we're gonna come back here once the water starts boiling. The stopwatch we need later. We're gonna hear the water bubbling, literally. Let's have a look into the lab. I'll bring up here the instructions. There's your lab report. Here's the link. I'm currently doing the virtual lab. You're gonna look through the tutorial if needed, and this is pretty much the only table we're gonna deal with, and I pre-filled it already with the mass that we used for the metals. And be careful, this time for this lab we're gonna stay with grams, so I filled them in for you, so don't need to change it. The units will be in joule per gram degrees Celsius, so there will be a gram notation here. We're going to determine the mass of water, and I'm going to show you how to do one of them, how to fill in the data for one of them. I'll let you calculate the specific heat capacity. The formula is down here. So it's Cm equals the mass of water. Whenever it says W there, it's water. Specific heat capacity of water, 4.18 joule per gram Kelvin, and the change that the water experiences over the mass of the weight we're dealing with, and the change that the temperature of the mass will experience, and I'll show you all that. Here's our table then. So our goal is to determine, obviously it's not water, but our goal is to determine what kind of specific heat capacity we have here, and then say, hey, is it chromium, is it copper, is it bismuth, of all things. And because we do it for 5 masses, we get 5 values down here. They should be all very close, maybe not exact. So we're going to ask you to calculate the average here, do a little statistics on it. With the spreadsheets, you can use a nice equation, equals average, or and the standard deviation. So how much of a spread do we have? So can we really distinguish, maybe, I don't know, these two things, you know, cobalt, copper? If we have an experimental error or standard deviation of 0.05, you know, we probably cannot, right? So it also gives you like an expected value, right? But we don't need to calculate the percent error here. I'm just gonna copy that table for now. Let's have a look back into the bench. It's not boiling yet, so like I said, start easy. Start turning on the lab. The water, I'm gonna put the table in here. Let's make that a little wider, so we get everything on one page, maybe. Oh, it's still a little bit up and down. If I increase it, maybe make this a little smaller. Now we see, I'm gonna work for you this like the middle weight, the 300 grams, and we're gonna determine these columns all the way down here, and I'll let you calculate the specific heat capacity. I think you should be able to do that. And that's the only table you're going to bring back into your lab report, where you're going to answer some questions here. starts boiling. But we can do some work before that. So actually I hear it bubbling now, and that's a good thing. You see the bubbles going up. All I do at this point is I'm going to grab that 300 gram mass, and the tricky part is we cannot grab it with the glove. We have to grab it with these tongs. So these masses only can be handled by the tongs. That's the first thing I want to mention. We'll let it just sit there, and that's cool. Um, we have to determine how much water we have here, and you see it's in a graduated cylinder and has what's called a meniscus. And for that purpose, we need to zoom in. So this meniscus is like a little bow. It's high on the sides because of surface tension, and low in the center. And we want to look at how much mass or volume there is, and for water it's the same as mass, just at the center. So we put the index finger there, and I go over here, and it's kind of an estimate. I think it's not 190. I don't definitely know it's not 180, and so it's kind of in the middle. So these are chunks of twos. So I would go by maybe 185, 184 milliliters, right? Um, and we'll need that in that table. So go back out here. I'm going to memorize that now. We're going to pour that water in there. And we want to know the temperature of it. So we take this contraption here. On the right you see a thermometer, on the left is like a little stirrer. And we dump that in here. And we're just measuring the temperature, the initial temperature of the water. It's going to be 19.6. You can steer here. A click is 5 seconds of steering. It won't change. So we know naturally it was 19.6 degree, the water, before we add it. It's just the environment temperature, so there's no problem. We can just grab it here again and put it at the side. Time to go over to the spreadsheet, write all this stuff in here, otherwise I'm forgetting it. So the mass of the water in grams, because the density is 1 gram is 1 milliliter. We had 184, I would say, milliliters. Beginning temperature of the water was 19.6 degrees. Beginning temperature of the mass. So it's kind of a trick question because we all know the temperature at which water boils. I hope you know. It's an easy number to remember, 100 degrees, right? And what we want to find out now is the final temperature when we dump or when we move that weight into the hot water. Let's do that next. Now it's really boiling well. So we are all set here. We're going to grab it with the tongs again. And we'll put that inside the dewar. Now we're going to put the tongs on the side. And we close that. And we're going to see the water rise. Not surprising. We have something that's at 100 degrees. We have 300 grams of an unknown mass putting into water that's about 20 degrees. So it will be changing. The water temperature will rise, but at one point it will stop rising. You should steer it a bunch of times here. Let the water boil. Get used to the bubbles, bubbling sound. You'll hear it. So it's about stable now, right? The 40.5. So now the instructions is, the tutorial says you need to turn on the clock here, the stopwatch, and wait a minute and see if it's not changing. My experience is that once you steer twice, this won't change much. If it at most a 0.1 in the back, but you can wait one time your whole minute. But I don't want to waste your time. So if for one of them you do it, for the other 4 masses you're going to do it for all of them. Just go with what is shown here after you steered once or twice. So it's 40.5 degrees. It's what we have, so 40.5 degrees. That's what we go back into our table and we write 40.5 degrees. So now we need to do this change. We need to calculate the changes of the water and the changes of the mass. For the changes, always use final minus initial. So it's always equals. The temperature final was 40.5 minus, and this is for the water, the initial water temperature was 19.6. And it's going to be positive, right? The water's temperature increased. The change of the mass was equals the final one, the 40.5, minus its initial. It's 100 degrees. So it's negative. But as you know, this equation here has a negative sign. Where is my equation now? Okay. As you see, this equation has a negative sign in front. So that will help us when you do this calculation. And I'll let you do this. You're going to link to the cells that have the mass of the water. The specific heat capacity of water can help you. You have it here, 4.18. So you could write it just in the equation, or if you want to link to it, right, you can always write it here below, 4.18, and then use that and create the formula in here. And I'll let you calculate that. And you do this experiment for also 100, 200, 400, and 500 grams. You're going to get 5 values down here. Hopefully they're close. Now, when you do these other experiments, you can't just continue, right? We have now water at 40.5. Things are boiling. So you have to start over again. The only way to do it is you're going to say reset the lab, and you're going to begin the lab again. Maybe you take a different glove. But you're gonna, first thing is you put that in there, and it might be different. So this time it's 20.4 degrees, okay? But I'm sorry, there's nothing in there. Sorry, let's make it sure it's in there. So it might be slightly different. Check the water level, it's close to what we had before. Let's pour it in here. That aside, that on there, stir it. So as you can see, it's 20.4, it's just the environment temperature. So your value that goes into the table for whatever you choose as second, right, might not be 19.6. This might be 20.4 degrees, right? The initial temperature of the mass will be 100, right? You're gonna boil it again, and then you're gonna get the final temperature, and then you can just drag these equations over, right? I don't know what the final temperature will be. We'll produce an arrow here. But so expect when you do a reset of the lab here to get different initial temperatures. That's the only other thing I want to mention to you. And you're going to calculate those things. Oh, let's say you find, like, I just fictitious, 0.32, 0.33, 0.3229, and these are wildly wild guesses. So 0.35. If you want to calculate the average very quickly, you're going to type equals average of. You're going to select those cells, and you can watch the equation up there. And if I press enter, I get the average. And you can do the same thing, equals SDDEF, standard deviation of these ones is that much. So the way you typically write it then in the lab report would be 0.32, and then you say plus minus 0.02 joule per gram Kelvin, or joule per degree Celsius. And if you can't make the Celsius, just to make a C. When there's changes involved, right, the Celsius and the Kelvins are the same. On the absolute scale, they're not the same. 0 degrees Celsius would be 273 Kelvin, but you know, if you go to 20 degrees Celsius, the change would be 20, and in Kelvins it would be 293, so the change is 20 Kelvins, the same thing, right? So that's why this doesn't matter. And then you determine this value, go to the table, and find what metal we're talking about here. Let's bring up the lab report for a second. Sorry, I wasn't ready for that, but I'll find it for you. I didn't have it up here. So you're going to copy the table here, a little bit here. So here you need to what is the specific heat? The mass and the capacity. Calculate the average specific heat based on the calculation. What is the metal? Define me these two key terms. Shouldn't be too hard. Oh yeah, we do the percent error compared to the expected value. Okay, sorry, we do the percent error. Even acceptable. Some of your, and then list and describe 3 sources of error. So think about what happens when we open up the calorimeter uh, calorie meter, and it's also called a dewar, and how long it takes to move the mass over, right? And then there's another assumption here, right, that we poured all the water in. Maybe, you know, we didn't measure it accurately, and I'll let you think about a third one. There are plenty of reasons why there's a difference between the expected value, and explain your own words what a own words what a calorie meter, how it works, right? Define basically this term. Explain it to someone. That's all there is. Not a hard lab. 31 points. I think nice lab after this. Hard ones, the momentum lab we did, and the work lab. I think these were much harder than this one. So enjoy it, and I'm looking forward to seeing your work. Just want to see if I left the heating plate on. Oh no, I started the second lab. So again, when you enter it, I would just say turn it on, and you need to wait until it's boiling. You can put the mass in there and then wait, work on something until you hear it bubbling. And enjoy the lab. Let me know if you have any questions. Thank you for watching.